back to my YouTube channel. If you're new here, my name is Tian and I'm an aspiring software developer. This video is another p5.js video, and I've decided to make another example video where it's sort of like it builds upon the previous video where I spoke about arcs and animating a spinning arc or a spinning circle and all that stuff. Although the program and the code to approach this video might be a little bit different, but I think it builds pretty neat into understanding how to construct basic shapes and how to animate it. So this video is about a very common pattern, very common curve that is visible within different realms of academics like physics, or just it looks aesthetically appealing. It's the Lissajous it's this curve. I can't pronounce this word. I apologize, but it's this curve. I don't know if you guys have seen these types of curves before, but if you guys have done things like frequency or graphs or using x and y coordinates in your math and maybe in your secondary school days, then I think that you guys have came across with something like these. It relates well to frequency, and to top it, to have the cherry on top of just the basic curve, by the end of this video you will know how to animate the curve. Let's start with what is this curve, or what is this graph? So the graph, as you can see here or in these examples, it describes a complex harmonic motion. The curve, as you can see, it is largely dependent on the ratio A over B, which you will see later on when I show you guys the formula. And the different ratios will produce different frequency. So as you can see here, you don't have to animate it, but you can if you want. The ratio and the angle, it changes the curve. It looks so aesthetically appealing. I just want to get into it. All right, cool. So another thing to note is not only are the curves, they're pretty and aesthetically appealing, they have practical applications as well, especially in the realm of physics or frequency. So first of all, how do you approach this? How do you even approach, begin to construct these type of curves? If you go onto this website, right, and you scroll down a little bit, it tells you about a bit about the history, and then it goes into having two equations. These two equations will help you to get the x and the y directions, and it breaks down pretty neatly for you, in which if you understand these two equations, you can then apply them into your p5.js, and then you would be able to make it and to animate it, which I think it's pretty exciting to get into. So, understanding the equations. So in here, let's just dissect the equation a little bit. Let's start with the capital A and B. What is A and B? Well, A and B, as you can animate here, A and B are they represent the amplitudes in the x and y direction. So if you move A and B, you can see how it starts to change. Let me pause this for a minute. I'll come to the angle a bit later. And then you see this normal A and B. That normal A and B represents the number of horizontal lobes and the number of vertical lobes. So for example, if A is 3 and B is 2, let me just make it so that you can see it better. Right, so B 1 2, but A 1 2 3. You see how that starts to apply to the curve, whereas the angle, it angles. So if you focus onto this point up here, by angling it, it starts to, you know, move. And so that sums up pretty well with the equations. Now let's jump into the code and I'll show you how to break it down step by step. Actually, let's jump back here. Oh, I can't copy it, can I? I'll be right back. Let me just speed up the code when I'm, typing out the equation, and I'll translate it into JavaScript terms for you. Let's start with t first. Let's have a variable that could change t because t will be changed. So you cannot have a constant t because that would maintain t to be the same throughout the program. Now once you have the t, let's build the setup function for p5.js, and let's create a canvas that is, say, 700 and 700, and let's have the background to be in a black color, so 0. Background here is the background of the entire canvas, so just letting you know. And let's have the draw function. Okay, let's break this down for a minute. So you would want to probably have, let's say, a circle that draws out the curve. Every time that circle is drawn into the draw function, that circle would leave a trail, so you would start to see the curve. I can only think that a for loop in JavaScript would be the best method to approach this. For my Python viewers or developers, a for loop in JavaScript, the syntax is a bit different. Let me show you what I mean. That right there is a for loop in JavaScript. Now, this for loop takes an I variable and set the initialization for the I variable to be 0. The limit for that I is 1. And every time that for loops through it, it increments by 1. That's the logic of a for loop in JavaScript. And let's just run my HTML for a bit. Okay, so let's just split the screen right here. My intentions for the curve is to, every time the circle draws, it leaves a trail. The only way to emulate that trail is to have an RGB A value, where the A is the alpha value. It can change the color of the canvas. For example, if you want to have fill, which sets the color to fill certain shapes, you would see the alpha value here. And that alpha value would then again modify the color of the shape. So let me show you what I mean. Cool. Now I have an alpha value by 50, in which you will be able to see it better when I have an actual circle to emulate. Let us apply the x and y into JavaScript. Let's start with my x first. X equals to a right here, which indicates the amplitude in the x direction. So you see here the x direction, which is pretty cool. 230. Let's time that by sine. And then for my a, which indicates the number of horizontally aligned lobes. So if I increase it, then you would see, the number of horizontal lobes. And let's have my horizontal lobes to be 3. Then I times it by t, and then I add pi divided by 2. My angle will be 90. Now let's do my y. space this out a bit more so it aligns well. It's spaced out evenly, which I like. Let's have my y be yeah, again, amplitudes in the y direction. So let's have it to be equal to a, and then times it by sine, and then have my y to be 1, yeah, because b right here, yeah, determines the number of vertically aligned lobes. So you see 1 times by t. Now let's have my fill for my ellipse to be white, and then draw out my ellipse, yeah, ellipse to be 350. The x first. No, that's too no 310. And then I add my my x, and then 310, adding my y into it. Let me pull this back up and have the width and the height of my ellipse to be in 4 and 4. And then I can increment the t to be 0.01. Ta-da! Whoa! There you go. You have your curve drawn out perfectly, all in accordance to what you have planned. Cool. Now let's test what I have input here into this graph and animate and not animate it, but see what it does. So 0.5. What's my a? What's my little a? My little a is 3, and my little b is 1. And then don't animate it, please. 0.5. Cool. And then have my big A to be that's too big, but you can still see the shape being applied in here and in here. I'm just not animating it at the moment. Now let's go back into the program. Let's jump back into the program, and let's just, have fun with it. Experiment as many numbers as you can. What's gonna happen if I remove this? Let's see. It would still work. I wonder why. Why doesn't the alpha diminishes? Oh wait, that's right. I have my fill right here for my ellipse. So my fill is drawn first, and then my ellipse. Remember, the logical order and the logical flow of your program is super important. That's why this program didn't crash when I removed that line. What will happen if I, let's cover this for now. What will happen if I change the big A and B where it represents the amplitude in the x and y direction? What's gonna happen? Still relatively the same, but it's a lot closer to this one over here. Now, what's gonna happen if I increase t? Oh, static. It gives me a static vibe to it. Pretty neat, right? What's gonna happen if I increase it even further? Ooh, okay. Cool. Okay. What's gonna happen if I... Okay. If I make it even slower than my original one. So it goes slower. Okay, starting to see. You start to see if you experiment around, which I highly encourage you. If you watch my videos or any other videos on p5.js, I would highly recommend that you take the initiative to experiment with your programs if you have time, that is, and just mess around with the numbers to see, you start to see the logical flow of it. Okay, one last experimentation. What's gonna happen if I increment the limit of my I to 5 and change this to 1? It draws faster. I can't figure out why, so tell me in the description down below. That's the challenge. But yeah, that's it from me for this video. I hope you guys learned a thing or two about programming, especially with this curve, and that I look forward to see you guys again in another episode. And I'll see you guys next time. As always, this project will be linked in my GitHub in the description down below. Yeah, and I hope everybody stays safe, and I'll see you guys soon. Bye!